Okay, give me a minute. Okay, let's get started. So today we'll go over like the sort of like the last part of your homework, implicit differentiation and inverse trig functions. So let's go over that. So let me motivate you as to why we do this. So if I told you like y is 2x plus 6, then what is y prime? Or if you like, some books write, or if you like dy dx. Yeah, 2, right? So all the stuff we learn, like product rule, quotient rule, chain rule, it's when you could write your function as a something with all the x's, right? You could write y in terms of x. So like, what if it's not, right? What if it's like this? Then your first thing would be, if I asked you to like, what is y prime? What would you do? Well, I can't use like, product and quotient rule a priori, right? I need to write like y in terms of x, right? So in this case, we could just do that, right? We could say this is how do you say, like what, like 6x equals 10 plus y is 6x minus 10, right? So in this case, you could say y prime is 6, right? So this is 2, y prime is 6. So in the easiest case would be like when you could just isolate y. But like now the third question is, what if I have something like this? Cosine of x plus y equals y squared. And then I ask you to find y prime. do you all see that this is kind of hard? Because I mean, if you didn't know implicit differentiation, right? If you try to isolate y, how would you isolate y? You can't really do this, right? I mean, to isolate this y, you would take cosine inverse, right? But then how do you get y? How are you going to get y equals something in terms of x? Well, I need to somehow combine these terms. So like, like y minus cosine inverse of y squared negative x. Now, how can I write this, as y equals, right? It's kind of hard, right? Because to get this y squared out, you need to take cosine again. And taking cosine that does like, you're basically you're going in a circle, pretty much. Right? So sometimes it's kind of hard to write something as like y equals a function of x, right? F of x. Because, I think most of you, it's implied is y is a function of x. But, in some cases, it's hard to write it as y equals something in terms of x only. So basically, we need a way to differentiate when we can't do that, when we can't just express it as a function of x. Is this clear to everyone? I'm just giving a motivation, but is this clear as to why we're learning implicit differentiation? So, yeah, everyone follow so far? Okay, cool. So, with that being said, well, how are we gonna do this? Well, like for example, what is derivative of, like, say, cosine of y, right? So I don't know how to write y as a function of x, but whatever it is, let's let y be f of x, right? Then I don't know what f is, right? If I knew what f is, I could just take derivative like I normally would, right? With product rule, quotient rule, all the rules, right? Chain rule. So I don't know what f is, but let's just say y is a function of f. Then this is cosine of f of x, right? So you see that this is really just chain rule, right? This is where the outer function, chain rule. This is where the outer function is cosine of x, right? Inner is f of x, right? And what does chain rule say? It's derivative cosine is negative sine, and I plug in the inner times derivative of the outer, right? So I'm not gonna write like all the chain rule thing. So I mean, on Tuesday I did, so I might go a little faster for chain rule this time because I expect, hopefully you all know how to do chain rule by now. So you see that this is just negative sine of y, and then we call this y prime. Yeah. So, basically the word of advice, in English, right? How do you take derivative of this? Well, just take derivative like you normally would, right? Take derivative like you normally would. I don't know how to write this. This looks really bad. Like you normally would, right? But when you derive something with y, you need to multiply by y prime. There, let me just say, there is a y prime. Because normally, right, if you take derivative of x, this is 1, right? So here, a derivative of, I mean, I guess it makes sense, right? You just move the prime in. Yeah. So that's really the only catch. So whenever you derive y, you get a y prime. So here, right, you take derivative of cosine, that's negative sine, so it's just this. But you took derivative of something with a y in it, so chain rule tells you there's a y prime. So all in all, this is the answer. So everyone clear on this? Yeah. So so we call implicit differentiation. Basically, you could think of it like find y prime without solving for y. Yeah. Okay, so let's do examples. Okay, I'll go easy to hard. So examples, find. So some books will write dy dx. Yeah. Some books will, or if you like, this is y prime, right? Or y prime. By implicit differentiation. So here, let's do the example x squared minus 4x squared y plus y squared is 4. Oh, by the way, this might be useful for that question with like, find horizontal tangent. You know how you have like 2 something in terms of y equals something in terms of y. So you could implicit differentiate that, right? Because again, horizontal tangent means y prime is 0, right? So you're still trying to find what y prime. So once you find what y prime is using implicit differentiation, you set it equal to 0, and then you find the x values, right? So, okay, anyhow, so let's find y prime, right? So let's differentiate both sides. So again, I'm going to ask you all, what's derivative of this? This should be easy. So this is power rule, right? 2x. And then I'm just going to put minus 4, right? Parenthesis. So how do I differentiate x squared times y? What rule should I use? Good. So derivative of x squared is 2x times y plus derivative of y, remember, is not 1, right? Some people think this, which is true, but derivative of y is y prime. And then I multiply by x squared. Okay, that gives me that term. Now here, again, take derivative like you normally would, right? So how would you differentiate x squared? You would differentiate by, you get 2x, right? So here you get 2y, and then whenever you differentiate y, something with a y in it, you multiply by y prime, right? I don't know why I wrote that really straight. So, okay. Now, and then what's derivative of 4? Yeah. No, it doesn't. I just write y prime because it's faster. I don't want to write dy dx all the time. So okay, it's a good question. So for those of you who are going to like math, I don't know, like what is multivariable? Is that math 2e? I think 2d 2e. The prime is bad because let me just really side note for those, since you asked, like, because if you have like because right now we're in single variable, but if you have a function of 3 variables, right? This tells you with what variable you're differentiating with respect to. So here, I'm differentiating with respect to x. So I'm treating all the y and z's as constants. And then here, it tells me I'm differentiating with respect to y, right? But like if I just write f prime, I can't tell whether if you mean this or if you mean that, right? And similarly, or this, right? But since we're in single variable, right? We all know when we write derivative, it's ddx, right? It's not ddy, ddz. So the prime, doesn't matter in our case because we're in single variable. Okay. So let's FOIL 2x minus 8xy minus 4x squared y prime plus 2y y prime equals 0. So at this point, it's just algebra, right? How do you solve for a variable? In this case, our variable is y prime. Well, you move all the variables to one side, all the things without variables to the other side, right? So, in this case, you move all the y primes to one side and then all the non-y primes to the other. So I'm just gonna move, this to the other. So I get negative 4x squared y prime plus 2y y prime is equal to, what is that? 8xy minus 2x. And then you factor out y prime, and then divide out, right? Please tell me if I make an algebra mistake, by the way. But this, assuming I didn't, this should be y prime. Yeah. Everyone good?
Yep.
Good. Okay. So I'm going to move to something harder. So let's do this. X plus y. So again, the questions will be, find y prime. So today we'll be practicing at least for most of the discussion, we'll be practicing implicit differentiation. Okay, so again, let's find y prime. Let's derive both sides. So what rule do I use to derive this? Yeah. So a lot of people just add a y prime. So remember, you only add a y prime when you differentiate something with y, right? So here in the bottom, I'm not differentiating anything, right? I'm just squaring. So you see that there's no differentiation happening on the bottom. Now the top, I take derivative of 2x. That's derivative of x squared, which is 2x, and I multiply by this. So no, there's still no y prime, right? Like I didn't differentiate anything with a y in it. But here I do, right? I take derivative of x plus y. So what's derivative of x plus y? Well, derivative of x is 1, right? Derivative of y is y prime. And then I multiply by x squared. Yeah. And this is the same as before, right? 2y y prime. And then derivative of 1 is 0. Everyone follow that? So I'm saying people make mistakes because they're tempted to put like a y prime here or here. So make sure you don't do that. Okay, so let's clear denominators. I didn't really prepare for things to be ugly like this, but 2y y prime x plus y squared. Okay, and then this is 2x squared plus 2xy minus x squared plus y prime x squared equals 2y y prime So I have a y prime term here, y prime term here, right? So let's move it all to one side, right? So I'll keep things here. And then let's move the, y primes all to one side. So exact same way as to how you would like solve an algebraic equation, right? With like y prime as your variable. Minus y prime x squared. Same exact thing, factor out your y prime. 2y x plus y squared minus x squared. And then voila, you have your answer. So y prime is 2x squared plus 2xy minus x squared over 2yx plus y squared minus x squared. Everyone good? Things are gonna get more and more tricky. So okay. So let's move on. I'll do two more. So sine of x plus y equals cosine x plus cosine y. So in this case, how do you, let's take derivative of both sides. So I'll leave more of this to the class. So how do you derive sine of x plus y? So derivative of sine is what? Good. And then cosine of x plus y, right? So again, take derivative like you normally would. And then I chain rule the inside. So what's derivative of x plus y? No, it's not 2. No. Yeah, 1 plus y prime, right? Derivative of x is 1. And then derivative of sum is sum of derivatives, right? So derivative of x is 1. And then derivative of y is y prime. I mean, it's good to make mistakes here, right? So you don't make it like on the quiz or on the final. Okay. This is easy, right? Derivative of cosine is just negative sine, right? And then here, same exact thing, right? Derivative of cosine is negative sine, but I took derivative of something with y, so multiplied by y prime. And then at this point, it's just same exact thing. Isolate y prime, right? Y prime cosine of x plus y equals negative y prime sine y minus sine x. So let's move, let's move this to this side, this to this side. So y prime cosine of x plus y prime sine y equals negative sine x minus cosine of x plus y. And then you're done. You just factor it out, right? I did chain rule. This is the chain rule. my outer is sine x. My inner is x plus y. Okay. And then y prime is negative sine x minus cosine of x plus y over this, right? Everyone good so far? Yeah, it's getting harder. But I mean, I feel like this is sort of like chain rule, right? If you once you do more and more of it, it becomes natural. So, okay, and this is the answer. Okay, let's do one more. And then I'll change the problem type. X square root. Let's do something with square roots. X plus y equals x to the fourth plus y to the fourth. Okay. How would you differentiate square root of x plus y? Point 0.5 times x plus y. No, it's not. It's not 0.5 times 0.5. Are you saying is this 1 plus? Yeah. So how would you differentiate 1 over root x? It's 1 over 2 root x, right? So this is 1 over 2 root x plus y. Chain rule, derivative of x plus y is 1 plus y prime, right? And then, yeah, that's it. And then derivative of, what is it? Yeah, derivative of x to the fourth is 4x cubed. This is 4y cubed times y prime. Oh, I see. Yeah, you. I mean, if it confuses you, just think of how would you differentiate like 1 over root x. I mean root x. So okay, so again, let's clear denominators. 2 root x plus y plus 4y cubed y prime. 2 and the 4 become 8, right? 8 root x plus y. Again, isolate the y primes, right? So y prime minus y prime, 8 y cubed y prime square root of x plus y. Yeah, square root of x plus y equals, what is that? 4x cubed. Oh, this is 8 too. Huh. I don't know why I didn't write 8. So, so 4 times 2 is 8. So, 8x cubed. And then, why does my pencil not do anything? So 8x cubed square root x plus y minus 1. And then from here, right, you factor out y prime and then you're done. Y cubed root x plus y. So to answer the previous question, once you set whatever y prime is equal to 0, you could find your what do you call it? X values, right? So I mean, from the graph, can you see what the y value is? Like, I forgot what the graph. Let me just finish writing this. So this is your answer. I forgot how the graph looked like. It looked like something like this, or like
it's like an infinity sign.
Like that. Okay, this is estimate, right? So like, do you know the y values here?
No, not exactly.
Not exactly, huh?
Like we see the graph, but it doesn't tell us. It just says about, like in the little description of the graph.
What does the okay, actually give me a moment. I'll pull up WebAssign so I can see what the give me a moment.
Yeah, it's kind of wacky.
Let me pull it on my computer. What number is it?
19.
19. Okay. WebAssign. Homework 5, right?
Yeah.
So okay, so I don't know what the equation you get is, but I think the one on my screen is like this. I mean, the numbers might be different, but
Yeah, numbers are a little different for me.
okay.
The
So
base equation is the same.
I think you should get y prime is 49x. I mean, on like on my thing, 16x x squared plus y squared. So this is like for me. So anyway, you set it like equal to 0. So set this equal to 0, and let's see what we get. So I mean the numbers are different, right? But the algebra should be the same. So 49 minus 16 plus y squared equals 0, right? So you either x equals 0 or you have this, right? You have x squared plus y squared is 49 over 16. Okay, I'm gonna be lazy and erase all this. Hopefully you all got this. So now that you have this, now first question, right? Can x be how do I say this? Can x be 0? Does x equals 0 give a horizontal tangent?
No.
Because if x is 0, right? Like y is 0, of course, from this equation. And you see, like, if you just look at the picture, like the tangent is not, the tangent line is not horizontal at the origin. Yeah. So really it's only, so now let's plug in, right, 49 over 16, right, to this equation, right? 8 times 49 over 16 squared equals 49 x squared minus y squared. If you, let me see, if I solve for this, what I get. So the 49 squared cancels out with the 49, and then the 8 cancels out with the 16 to get. So I guess you should get something like x squared minus y squared is like something like this, right?
Mm-hmm. Okay.
Good.
Yeah.
And then you're done, because hopefully you got the rest, right? Because you have two equations, 2 variables. Use your pre-algebra or algebra 1 skills and solve for it. Yeah.
Yep.
Everyone good with this? I mean, from here you could solve for what x and y are.
Yeah.
Okay. Cool. Okay, let me turn off my computer really quick. Okay. I'm gonna move on. So find equation of tangent line to curve. So this is like the one, probably like the most common question you'll see in Math 2A at given point. I'm sure some of you are tired of it by now, but was x cosine of y at 0, 0. Okay, so again, I'm gonna go a little faster. So how would you find y prime, right? The tangent line has point, it tells you 0, 0, and it has slope like y prime at 0, 0, right? So let's find y prime, right? So y prime is, what do you do here? You use product rule, right? Derivative of y is y prime. Derivative of and then derivative e to the sine x is chain rule, right? So you get e to the sine x, and then derivative of sine x is cosine. And then I have a y here. And then here is also product rule. Derivative of x is 1. So 1 times cosine of y plus derivative of cosine of y is, negative, so negative sine. So this is negative sine y, y prime. And then there's still the x. And this is actually easier. Instead of solving for y prime, plug in 0, 0 to make your life easy. So if I plug in 0, right, this is y prime. This is e to the 0, right, because sine of 0 is 0. So e to 0 is 1. This goes away, right, because y becomes 0. So this thing goes away. So this is just y prime equals cosine of 0 is 1. And then this is just 0, right? So y prime is 1. So my point is 0, 0. And my slope is 1. So this is just the line y equals x. Everyone clear? So what I'm saying is don't do this. Don't solve for y prime and then plug in, because it's gonna get messy, right? You might as well simplify stuff earlier. Okay, everyone good? Yes? No? Okay. So moving on. Derivative of inverse trig functions. So this is the last part of your homework. Of inverse trig functions. So ddx of, so these are rules you just memorize. 1 over root 1 minus x squared. Ddx of tan inverse is 1 over 1 plus x squared. Cosine inverse of x is sort of the negative. And then cotangent inverse of x is the negative. So I'll sort of go over like why, if you, in case, for people who want to understand it, like instead of just memorizing, like it's based on the triangle. So ddx of secant inverse of x is 1 over. Yeah. So, I mean, really quick, I could do examples for you. So you could do finish your homework first, right? But like, how would you find like g of x is cosine inverse of 6x, right? Well, what is g prime? Same exact thing, right? This is chain rule, right? It's chain rule with outer being cosine inverse of x, inner being 6x, right? So chain rule, well, what's derivative of cosine inverse? It's negative 1 over square root 1 minus, so x squared, but I'm plugging in the inner, right? So 6x squared, right? And then I multiply by the derivative of inner, which is 6. So I mean, it's the same exact thing. It's just you have these like new rules. So is everyone clear on this? So I know these are like I know it feels like I'm just slamming you with like 6 new things to memorize, but I'll sort of explain like how to get them if you want to understand it. So the thing you're gonna need is this. If you do recall the inverse function, when you compose, you get x, right? Like f of f inverse of x is x. And similarly, this is x, right? Sine inverse of sine of x is x. Do you all remember this? I know it, it was at the very beginning of Math 2A when we learned inverse trig functions. So, okay. So from here, right, let's derive. Yeah. So what I'm saying is let's derive this equation. What do I get when I derive? Well, this part is chain rule, right? Derivative of sine is cosine. So I get cosine and then I plug in this thing, right? Times derivative of sine inverse, right? This is the term I want to know, right? This is the term we don't know yet, right? So I'm sort of proving the rule, but equals 1, right? Now, cosine inverse of sine inverse, let's figure out what that is, right? So really quickly, sine inverse of x, is that a number or an angle? If you just look here, I'm thinking sine of it, right? So is sine inverse of x like a number or an angle? Do you take sine as sine of numbers or do you take sine of angles? Like sine of, I guess angles are numbers, but when you sine of pi over 4 is like an angle, right? So so sine inverse of x, this is just the angle such that sine of it is x, right? I mean, from what I wrote above. So sine of this angle is x. But what is sine? Sine is opposite hypotenuse, right? So opposite hypotenuse should be x over 1. So opposite over hypotenuse should equal x over 1. So, you get opposite is x, hypotenuse is 1. What does Pythagorean theorem say? Pythagorean theorem, right? I get question mark squared plus x squared is 1 squared. Question mark squared is 1 minus x squared. Question mark is square root 1 minus x squared. Okay, now, so what's cosine? Cosine is adjacent hypotenuse, right? So adjacent is this, hypotenuse is 1, so it's just square root 1 minus x squared. So derivative of sine inverse is this. Yeah, as you can see from the rule. And so whenever you, if you forget, and, and you should memorize this for Math 2B too, but if you forget that's how you do it. You use the triangle. Everything is the triangle. So yeah, and then the proof of the derivative of cosine inverse, tan inverse, cotangent inverse, everything is exactly the same as this. Okay, so hopefully that should cover everything for your homework. in restrict functions and implicit differentiation. So I'll go over more on derivative of natural log and like taking stuff to like the power of a variable next time. Yeah. Hopefully everyone should be good. Okay, yeah, I'll see you all Tuesday, I guess.